Today we're going to be looking at another one of Real Engineering's videos. This topic I get a lot of comments about. Imperial versus metric. Is the metric system actually better? Interesting thing is I've used both. I actually prefer metric most of the time, but at the plant that I worked at, we used Imperial, or the English engineering units. Don't know if you still say Imperial anymore. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's get right into it.
The time has finally arrived. The comment section demanding imperial and metric units has gone on too long. There can only be one measurement system. The British imperial system, like everything British, is based...
You're going to ask that, most of people in the world will just say metric. There's only a handful of countries that still use the other kind, US being one of them.
Antiquated units of measurement, like measuring your country's importance by counting the number of countries you have invaded and pillaged. A measurement that made sense 100 years ago, but it's time to move on.
Really? It does kind of remind me of the British Museum. When I lived in there, when I used to live in the UK, it was interesting seeing it as, here are all the places that the British conquered, rather than stuff that was actually British.
Weirdly, the British have mostly moved on from this method of measurement, and it is instead Americans who insist on holding onto it. Well, America, Liberia, and Myanmar, a prestigious trio. Now,
what else do those three countries have in common? I don't really know.
I already hear the people who refuse to wear masks in the comments. There are two kinds of countries, those that use the metric system and those that landed on the moon. You know who led the design team for the Saturn V?
When did Liberia and Myanmar land on the moon?
This guy. Listen to that deep Alabama accent.
This weight dictates the amount of fuel and the numbers of motors.
An American through and through. Ignore this photo of him. Those are just some German friends he made while on gap year in Europe. Look at all his friends. Let's count them. 1, 2,
what is this?
3, 4, 5, 6, 7, 8, 9 friends.
Okay, usually Real Engineering's videos are a bit more serious. This one seems a bit more of a meme video. And I'm good with that. I like looking at plenty of meme videos, but...
A popular man. This Alabama native used metric in
Alabama.
In fact, he despised British units. So much so that he designed a rocket during his gap year to fly to England to show them how great the metric system was. The Saturn V was designed, like nearly everything in NASA at the time, with a mixture of both metric and imperial units. Just read the mission reports for Apollo 11 for proof of this. It switches between inches and centimeters constantly. It's a mess. Anyone working with this report would have had to be hyper aware of what unit of measurement they were using.
That is one thing, having to constantly switch back and forth, and especially when you're working with, since a lot of things, like for nuclear power plants, for instance, are not manufactured within the US, so you have to get those units to convert correctly. If not, it can get quite expensive. During one of the early stages of construction for the new plants in Georgia, Vogtle Units 3 and 4, there was a safety injection. There was a nuclear safety related tank that was off by that conversion factor in terms of volume between liters and gallons or something like that. I don't remember the exact units that were wrong. The point is they got the units wrong.
Most of the design and science work was done in metric before being converted to imperial for the manufacturing and operational staff. One of the most mind-boggling examples of this is the guidance computer. It was coded in metric. Meters and kilograms are the language of science. But to ensure the astronauts could intuitively understand what those calculations meant, the displays inside the lunar module had to be displayed in British imperial units.
I remember that just in taking hard science classes, which is different from engineering. I think it was like a middle school science teacher or something. I think we were doing, it was like a chemistry lab or something where it said, now This thermometer displays in both Fahrenheit and Celsius, but in science we use Celsius. It's funny.
So, even back then, when computer power was extremely limited, the engineers had to waste precious computational time and power to conversion. And this isn't just a waste of computation power.
Back and forth.
Errors in conversion have led to an insane number of accidents through the years, some of the most notable being in NASA. In December 1998, the Mars Climate Orbiter took off from Cape Canaveral aboard its Delta II rocket. Over the course of its 9.5-month journey, the orbiter needed to complete trajectory correction maneuvers to bring it into an optimal orbit insertion altitude of 226 kilometers. However, as the time grew closer, calculations showed that the orbiter was entering Mars orbit in a far lower altitude, so low that it was likely going to strike the atmosphere and violently tear itself apart. This is exactly what happened. So, what went wrong? The orbiter was coded with metric units,
conversion.
So the thruster control unit was working with the metric unit for impulse, Newton seconds, but the controller was being supplied with pound force seconds, which differs by a conversion factor of 4.45, a massive discrepancy, a discrepancy that destroyed a $328 million project.
Yep, this is such a big example. It is one that has carried over into the nuclear industry. We study this event for unit conversions just like we study 3 Mile Island for configuration control or Chernobyl for control of special tests, among many other things. But yes, even though this is not directly a nuclear accident, we study it in the nuclear industry as if it was a nuclear accident because it was so costly of a unit conversion error, it always comes up.
1983, an Air Canada flight departing from Montreal ran out of fuel halfway to its destination in Edmonton. Why? The ground crew knew 22,500 kilograms of fuel was needed for the flight. They, however, needed to calculate how many liters were needed to be pumped.
Gallons to liters.
So, they used the density ratio to convert the weight measurement to a volume measurement, but they used the 1.77 density ratio, which was pounds per liter, instead of the correct ratio of 0.8 kilograms per liter.
Yep, especially when it involves derived units or even universal constants, such as the gravitational constant. It's a different number if you're defining it in terms of different units. It's just, you have to take that into account.
In less than half the required fuel load being pumped aboard. Luckily, the pilot managed to glide the plane down to an abandoned airfield, but that little boo-boo of a conversion error could have resulted in a catastrophic loss of life. These are two cautionary tales with disastrous consequences, but it tells you nothing of the silent screams into the void every engineer in the world lets out when they are forced to work with both units. It's just an unnecessary pain in the ass we could all do without. This is the reason we need to choose one measurement system. Mixing units not only is tempting fate with conversion errors, but it costs an untold number of hours for scientists and engineers around the world, banging.
And even people that, even before you get to the science and engineer level, just having to teach multiple systems as early as elementary school, when you first start learning about what temperature is, for instance, what length is.
Their head against tables, when they could be using that time for something more productive. I could end the video there, but we need to really hammer home why metric units are the superior units. So why is it better? Well, let's start with the fundamental unit of measurement. There are 7 base units of measurement, and with these 7, we can measure everything in the universe.
Well, I think it's better.
Think of them like the 3 primary colors of light. With these 3 colors, we can create any color in the universe by mixing them in just the correct proportions. We can do the same with these fundamental units of measurement. They are time, length, mass, temperature, electric current, chemical amount, and luminous intensity.
What's interesting is this is also how you get things like units for radiation dose. So absorbed dose, it's energy per unit mass, or joules per kilogram. For units of exposure, you're talking about ionizations, which you throw in the unit for electrical charge, the coulomb. Now that's mostly metric units. There are a few weird ones out there though, like ones that involve units like ergs, which I've never actually used. I've just seen it in some really old textbooks.
These measures, we can describe our universe. Velocity is a combination of length and time, volume is length cubed, density is volume combined with mass. These measurements are the language of the universe. So, let's see how the imperial system handles a very simple one, length. An inch is a standard unit of measurement for length in the imperial system. Let's imagine a scenario. You are designing a railing for a 1 mile long bridge. You, as a skilled and knowledgeable engineer, know that 2 half-inch bolts are more than enough to secure the railing down. The posts of the railing are 6 feet apart. Alright, how many inches are there in a foot? 12? So that's 72 inches. Every 72 inches we need 2 bolts. Our bridge is 1 mile long. How many feet is that? I don't know off the top of my head, and a quick Google search tells me it's 5,280 feet.
What gets even better is in the old-timey imperial units. Well, I guess this would be pre-imperial, but the unit of a foot weren't standard. The number of feet in a mile wasn't standard either. And this is in like feudal Europe time period, but it was even crazier. And yeah, I know it's 5,280 because I'm an engineer that lives in the US, but most people probably don't. And I can't say I blame them because it's a weird unit of measure.
What's 12 inches by 5,080? That's
and then you have nautical miles, which are a little bigger.
60 inches.
I don't know what that is off the top of my head.
That's 880. So we need to order 1,760 half-inch bolts. That felt cumbersome. Why do I need to remember all these numbers? Because imperial is a convoluted mess of measurement units invented by people who married their cousins. That's why. Now, let's see how much easier that is in metric. How many millimeters are there in a meter?
You see that sometimes, like in the units of radioactivity, the becquerel is a pretty simple unit, which is just 1 disintegration per second. But then you have the curie, which is 37 billion of those. Maybe they thought curie had that much more impact than becquerel as far as which scientist to name your units after, but 1-to-1 is a much easier unit. Even though you're going to end up with some really big numbers for becquerels, it's still easier to work with and easier to think about. Though a lot of people do use curies. You see that as a unit for liquid waste effluents, for instance, like for the Fukushima discharge is measured in curies typically.
In the name, milli, 1,000. Now, how many meters are there in a kilometer? Once again, it's in the damn name, kilo 1,000. Given a measurement in kilometers but want meters, just shift the decimal place over 3 places.
But for radiation units, yeah, you still can use milli or kilo for a curie or a becquerel or in REM when talking about absorbed doses affecting people. The units often seen are millirem or microsievert, which is another unit for that. So those are at least metric, but it can still get a little confusing.
No calculation needed. There is no room for error. It's a simply better system. Even within imperial, you have to constantly convert your units. Ounces to pounds, pounds to imperial tons, which for some reason differs from a metric ton by 1.6%. Again, in metric, there are 1,000 grams in a kilogram and 1,000 kilograms in a ton. In imperial, there are 16 ounces in a pound and 2,240 pounds in an imperial ton.
Yep.
Why? You aren't even following the same conversion conventions as your other units. This is insanely cumbersome.
There's actually only 2,000 pounds, but it's in a short ton. That's thinking of the long ton.
Chances of conversion errors even within your own damn system is high. Never mind having to convert to metric. You know what's even more insane? The word for mass and weight in the imperial system is the same.
Yeah.
Why? Because the pound was invented before we knew what gravity was.
pound dinosaurs modern day Apple incidence. Yes, you'll often see it as pound mass or LBM. I've seen that.
That's why. We just assumed mass and weight were the same thing when they aren't. So we have to specify in imperial whether we mean pound mass or pound force. I haven't been this confused since I watched Magic Mike. The most ridiculous thing about all of this, every single one of these imperial measurements are legally defined by the metric system. America is already using the metric system, and most of the population is oblivious to it. Freedom, America, guns, pew pew, hoorah. The foot is
basically America in 3 seconds. No, that's actually not America. That's just America. There is a difference.
Legally defined as 0.3048 meters. The pound is legally defined by 0.435
That's the best
kilograms.
part.
Why? Because the metric system is run by the International Bureau of Weights and Measures, a neutral international organization whose sole mission is to create a global language of science, who America is a member of. And they have succeeded in an awe-inspiring way. In 2019, the final metric base unit, the kilogram, stopped being defined by human artifacts and is now, like all other metric units, defined by the laws of physics.
Now that's one thing that always baffled me, is why is the kilogram a base unit and not the gram, because kilo has a prefix. And real engineering's not wrong in saying that. That's actually what it is, but I just always thought it was baffling to me, like why it was decided to have something in units that 1,000 of the thing is the base thing. I know it's a naming thing, but you wonder why they didn't just call that thing the base unit a gram, even if they defined a gram as something that weighs what a kilogram is today. That is to say, a gram is a little over 2 pounds. It's just one of the things that's always baffled me about metric units, because the base unit for length is meter, not kilometer. The base unit for energy is joule, not kilojoule. It's watt, not kilowatt. For radiation, absorbed dose on a person, it's rem. The base unit for absorbed dose is effective on for absorbed dose equivalent on a person is a sievert, not kilosievert. By the way, a kilosievert is a ridiculously high amount of dose, more than enough to kill you 100 times over.
In 2019, it ceased being defined by this hunk of metal and began being defined by Planck's constant, which is defined as 6.626 by 10 to the minus 34 kilogram meter squared per second.
Yep.
Of course, to use this as a definition, we need ways to define the meter and second. The meter is defined as the length of the path traveled by light in a vacuum in 1 divided by 299,792,458 of a second.
Now this is an interesting one, because there's a bit of circular logic in place of us knowing how fast the speed of light is based on how we defined it. Bit of mathematician's logic there. If you're interested in seeing my reaction to a video talking about the challenges of measuring the one-way speed of light, the challenges of measuring the speed of light, I'll pin that in a comment down below. But it's interesting that light is defined in our unit system, even though it's something we don't necessarily know as well as we may think we do.
Okay, so how do we define a second? A second is defined by the hyperfine transition frequency, which is the frequency of radiation which will cause an electron to jump from 2 closely spaced low energy states in a cesium-133 atom.
It's just so arbitrary.
Each of the base units are defined like this, using the unchanging language of the universe as its yardstick, or should I say, meter stick. It's a beautiful and inspiring language that transcends the realm of humans, and for that reason alone, you should strive to use the metric system.
It does, but it's also based on our own logic and how we define things, such as the light and how fast we observe changing state levels in a cesium atom, that sort of thing. It seems totally random and arbitrary to me, but it's a far more convenient system to use in terms of making it easier to work with the base 10 and simple unit conversions.
Understanding the language of the universe is a superpower.
It is, but again, we're kind of going based on our own definitions of the universe. I'm not sure I agree with that statement, but I still agree with the big point that metric is a more convenient system to use. I know I've sometimes used units in Imperial for describing specific nuclear power plant parameters, but that's because those are the units I am used to and I have commit to memory after several years of working in one, just because I happen to be at a nuclear power plant within the US. So perhaps a form of brainwashing. Well, let me know which one you prefer. And hey, if there's a strong argument out there for that's the way we've always done it, to continue to use Imperial, I'm all ears. Thank you very much for watching. I'll see you next time.